Hello and welcome to 10.2 Notes. Today's lecture notes is on finding arc measures, and your goal for today is to use angle measures to find arc measures. Okay? So first off, we're going to start off with a quick review. And so if we have this circle, angle ACB, as you might recall, is called the central angle. So this angle right here is called the central angle because the vertex of that angle is at the center of the circle. Okay, so you have a central angle. And then the measure of arc AB is a minor arc, right? This is a minor arc because it does not equal, it's less than 180 degrees in measure. It's less than half of a circle. If it's less than half of a circle, it's a minor arc. And then ADB is a major arc. A major arc is greater than 180 degrees. Okay? And remember, it takes 3 letters to define a major arc. You need 3 letters to know which way to go. And if it's 2 letters, it's a minor arc. So AB, just you go the shortest distance from A to B. But if it has 3 letters, then no, I can't go from A to B here. Okay, because it's saying I have to go through D. So that's the way you show somebody that you want them to go the long way. So again, a minor arc is less than 180 degrees and a major arc is greater than 180 degrees. Well, what happens if something equals 180 degrees? Then that's a semicircle, right? It would just be like that would be a half of a circle. Okay? All right, so moving right along. Today's new material is the measure of a minor arc equals the measure of the central angle. Okay, so please write that down. Copy that down. These are your notes. The measure of a minor arc equals the measure of the central angle. And also, the measure of the major arc is equal to 360 degrees minus the measure of the minor arc. Okay, so write those down, get caught up. And remember, you're in total control of this presentation, so if you'd like to pause it, fast forward it, whatever you'd like to do, feel perfectly free to do so. Okay, but for the sake of this presentation, I will continue. All right, so we have this circle. It has a 50-degree central angle. The central angle is 50 degrees. Okay, this angle is 50 degrees. So what would be the angular measurement of this arc? What would be the angular measurement of arc AB? Well, it's also 50 degrees, okay, because, hold on, let me change colors here, because of this right here. The measure of a minor arc is equal to the measure of the central angle. So if the central angle is 50 degrees, right, this angle right here, made from those 2 legs, then the measure of the minor arc is also 50 degrees. And then the measure of the major arc is equal to 360 degrees minus the measure of the minor arc, which would be 50 degrees. So we would have then the measurement of this arc, the angular measure of that arc, okay? Hold on, let me change colors again. Give me a moment. So the measure of this major arc is going to be equal to 360 degrees, right? The whole entire distance around from beginning to end point, minus the measurement of the minor arc, minus this part, obviously will equal this part. So you just subtract, and then you get that the measure of the major arc is 310 degrees. Okay? So please copy this circle down with the degree measures and the points Q, R, S, and T, and the degrees, like I said, 120, 60, 80. Please write all that down and copy that down that circle and describe the following arcs as major, minor, or semicircles. Okay, so write down this prompt. You can pause it if you'd like, but I'm going to continue. So the first arc is arc TQ. So the measure of this arc TQ is, hold on, let me change colors again one more time. is 120 degrees. That's less than 180, so it's a minor arc. Okay, a minor arc. And then, what about QRT? QRT is this. Oh, well, it's about time now that we have to figure this one out. Okay, that one was missing. It was purposely not given to you. But we know that there's 360 degrees around a circle, correct? So we have 360 degrees total around a circle, minus what we already know, right? We have an 80 degrees, 120 degrees, and 60 degrees. Okay? So if you do that calculation, you'll find that this portion is 100 degrees. Okay? So it must be 100 degrees. Alright, so we have that this is 100 degrees, and so QRT is going to be 60 plus 100 plus 80. So it's going to be 240 degrees, and that's greater than 180, so it's a major arc. Okay, it's major. And then TQR, hold on, let me go back and erase this here. Oops, I didn't mean to do that. Okay, we're back. I erased whatever we didn't need. So TQR, well, TQR is this right here, and that equals 120 degrees, right, plus the 60 degrees. So that is 180 degrees. And even though it really should have been drawn straight like that, it wasn't, so it wasn't drawn to scale, but 120 plus 60 is 180, so it's a 180 degree measure, and so it's 180 degrees, and it would be a semicircle. Okay, I don't know if I have room to write that, but semicircle. So 180 degrees is a semicircle. Okay, and then moving right along, what about arc QS? Arc QS is going to be 100 plus 60, so that's going to be 160 degrees, and that would be less than 180, so it's a minor arc. Okay, and then TS. Okay, so TS is this arc measure. Remember, it equals the measure of the central angle, and so it must be 80 degrees. TS is 80 degrees, and that is also a minor arc. And then finally we have RST, and RST is this whole thing right here, and that's 100 plus 80 again. That's 100, or 80 plus 100. It's 180 degrees. Again, that is half of a circle, so it should be 180 degrees and a semicircle. Okay? Okay, and moving right along, we have definition of congruent circles, and two circles are congruent circles if they have the same radius. So if you have a circle here, they both have, say, a 10-inch radius, then they are congruent circles, or equal circles, basically the same circle. Okay? And we also have another definition here. Congruent arcs. Two arcs are congruent arcs if they have the same measure and they are arcs of the same circle or of congruent circles. So copy that down, get caught up, and I think the best way to exemplify this concept is by actually doing a couple of problems. So that's what we'll do on the next page. Okay? So, is arc CD congruent to arc EF? Well, two arcs are congruent arcs if they have the same measure and they are arcs of the same circle or of congruent circles, right? So you have to go back to this definition and see if it meets that criterion. Okay, so do they have the same measure? Well, this, it's arc CD and arc EF. In other words, arc CD and arc EF. Okay, and this is a central angle of 80 degrees, and that has a central angle of 80 degrees. So this must also be 80 degrees, and this must also be 80 degrees. Okay? So yes, the measures equal each other, but there's another part, because there has to be an and, so there has to be something else here. And they are arcs of the same circle. Are they arcs of this same circle? Yes, there's only one circle there. So yes, there's only one circle there, and they do have the same measure, so they've met all the criterion. So yes, they are congruent. Okay? Next question. Is arc AB congruent to arc CD? So again, this is a central angle of 145. That's a central angle of 145. So this arc measure AB must be 145 degrees, and this arc measure CD must also be 145 degrees, right? Because the measures of the arcs equal the measures of their central angles. Okay, so the arcs do have the same measures, but there's another part. It says and they are arcs of the same circle. Are they arcs of the same circle? No, these are clearly two different circles. But it says, and they are arcs of the same circle or of congruent circles. Okay? So look where it says here, or of congruent circles. So if they're in congruent circles, then they are congruent arcs. Okay? So let's check that. Okay? Are these congruent circles? And yes, here's a radius, and here's a radius. And they both have those green tick marks. So they're showing that the radii, or the radiuses, right, plural, the radii of these two circles are the same. Therefore, they must be congruent circles. So then, yes, the two circles are congruent, and the central angles are congruent as well. Okay? So, last problem here. Is arc MN congruent to arc PQ? Well, again, you have a central angle of 120 degrees, central angle of 120 degrees. So both of these arc measures then equal 120 degrees. So far so good. We are on the road to saying that they are congruent arcs. But remember, we have the and portion. They have to be of the same circle. Obviously, these are two different circles. They're not the same circle. Well, what about congruent circles? Are these congruent circles? Well, this has a radius of 5 inches, and this circle has a radius of 4 inches, so it's a bit smaller. So no, these are not congruent circles. Therefore, no, the circles are not congruent, and so the arcs are not congruent. Okay, so are the arcs congruent? The answer to letter C is no. The arcs are not congruent. Okay, because the circles are not congruent. So that's the end of the lecture. And if you have any questions or concerns, please feel free to contact me at your convenience, and it would be my pleasure to help you out with any questions you might have. Okay? Bye-bye.